Today we're going to start to take a look at how we graph sine and cosine on a set of axes. So the sine and cosine functions can be graphed easily by considering their values at integer multiples of 90 or pi over 2 radians. In exercise 1, consider the functions f of x equals sine x and g of x equals cosine x, where x is an angle in radians. We're going to fill out this table of values, but since our measurements are in radians, I need you to go to mode on your calculator and change your mode to radians, and then plug in all of these values. So pause the video, convert them all, and then click play. Hopefully you got the same answers as I did, and you start to notice a little pattern here. Graph both the sine and cosine curves on the grid shown below. Clearly label which curve is which. All right, so we're going to plot those points. So at -2, first I'm going to do cosine in this purple here. At -2 pi, it's 1. All right, and then when you connect these points, it's like a wave. And this pattern will continue on and on and on. Now let's graph sine. Again, when you connect these, make sure you're doing it in a wave. Okay, they are very similar. All right, one thing that you do want to start to notice here is that sine starts at 0. So right here at the origin, sine is starting at 0, where cosine starts at 1. I like to say sine starts on the line because sine and line rhyme. Sine on the line. Now let's talk about our domain and range like we do for every function. So the domain and range of the sine and cosine functions are the same. State them below in interval notation. The domain is the same. I could plug in anything from -infinity to +infinity. The range, if we look at the lowest y value for both of these, is -1. The highest y value for both of these is +1. Now we would like to explore the effect of changing the coefficient of the trig functions. So now we're going to be graphing trig functions where we're going to have a number in front. Let's see how that changes our graph. So again, make sure you're in radian mode, which you should be. And in exercise 2, the basic sine function is graphed below. Sketch each of the following sine curves. All right, so I'm going to do these all in different colors. So first color here, let me do in blue. 2 sine x, you plug that into your calculator. You will notice that it stays the same at -2 pi. Then instead of being at 1, it's going to go up to 2. Then back to 0. Then instead of -1, it'll be down at -2. Back to 0, 2, 0, -2, 0. Next one, 4 sine x. Still starts at 0. Instead of going just to 1, though, it's going to go all the way to 4. Then to 0. Then instead of -1, -4. Now, -3 sine x. Okay, so it's still going to be starting at this 0. But remember, a negative in front, if you remember, indicates a reflection over that x-axis. And the 3, well, following the other patterns, if I am flipping, so instead of being at 1, I'm going to flip over the x-axis and be at -3. Then be at 0. And then instead of being at -1, I'm going to flip that over my x-axis and be at +3. And the last one we have to graph is y equals -1/2 sine x. So starting at the 0 again, and -1/2. So we're a reflection over and then only half of the value. So it's going to be -1/2 and a +1/2. And then we graphed all of our different functions. Exercise 3, very similar. The grid below shows the graph of y equals cosine x. Sketch each of the following cosine curves. All right, so it has the same effect here. So why don't you pause your video and see if you can do these 3 problems. Looking at my graphs compared to your graphs, see how you did. Again, it follows that same pattern as above with those sine functions. So for instance, for that first one, it was 3 cosine x, so instead of just going up to 1, it goes up to 3. All right, what that number in front is called, it's called the amplitude. And the amplitude is the height of the function. So the coefficient of the trig function tells you the amplitude. So when you see a number in front, that is your amplitude. We do not include the negative number when you're talking about height. If you're talking about how tall somebody is, you wouldn't say -2. So you always talk about positive numbers. If there is a negative number, we just know to flip that over the x-axis. Now we're going to talk about vertical shifting. So just like all of our other functions, which is really nice across mathematics, is that it has the same indication here. So if we have a function and we have a plus at the end, that's a vertical shift up. If we have a minus at the end, that goes down. They're still vertical shifts, just like all other functions. So consider the function f of x equals sine x plus 3. How would the graph of sine x be shifted to produce the graph of f of x? Well, since it's plus 3 at the end here, I know I need to go up 3 units. So let's do that. Let's take all of our points and move them up 3 units. 1, 2, 3. Exercise 5. Consider the function y equals 2 cosine x plus 1. Sketch the graph on the grid to your right. Give the equation of a horizontal line that this curve rises and falls 2 units above. Sketch this line on the graph. We will call this line the midline, and then we have to state the range. All right, so I think it's very, very helpful if we have our original just y equals cosine x graph on our axes. So let's plot that first. I'm going to use this color. Okay, so if you look above and copy the cosine x graph, you'll see this. And now I know that I need to go up 1 unit and that my amplitude is 2. Okay? So I need to shift everything up 1 unit, but my amplitude is 2. So I'm going to go up to where it would be if I just plotted my amplitude. and then I'm going to go up 1 unit from there. Okay, so first I'll do the amplitude of 2 would be right here, but I need to go up 1 more unit, so that'll be right here. And I'll put a big mark there. Okay, if my amplitude was 2, it still stays at 0, but I need to shift that up 1 unit. Okay, my amplitude was 2, I'd be down here at -2, but I need to go up 1 unit. 0, again, I need to go up 1 unit. Should be at 2, I need to go up 1 unit. You can kind of follow the pattern from here on out though. Now it says, give the equation of a horizontal line that the curve rises and falls 2 units above. So I need to find out where the middle of this is. All right. So when I look at this, I notice that the middle would be right here. Or if I drew a horizontal line right here, my function is now going up 2 units from it. And it's also going down 2 units. So that's how I know that would be the middle. We call this line, guess what? The midline. And the equation would be y is equal to 1. All right. Since we moved up 1 unit, that shifted our midline up 1 unit. Okay, there is a relationship between up 1 unit and the midline being at y is 1. State the range of this trig function in interval notation. Okay, my lowest point here is at -1, and my highest y value is at 1, 2, 3. Exercise 6. Sketch and label the functions 4 sine x minus 2 and -3 cosine x plus 3. Then state the ranges, minimum, and maximum values of each. All right. So when I look at this, I know my amplitude is 4, and I know that I need to move down 2 units to get to my new midline. So my midline is going to be at -2. So I like to draw a nice dotted dashed line across where my new midline is. Okay. If I look at my original sine graph would start on this midline, go up 1, back down, up, down. But instead of just going up 1 and down 1, I need to go up 4 and down 4. So from my midline, I'm starting on the line because that's where sine starts. I'm going to go up 4 from the new midline. 1, 2, 3, 4. Back to the midline. Down 4 from the midline. 1, 2, 3, 4. Back to the midline. Up 4. Back to the midline. Down 4. Back to the midline. So my minimum value, my smallest value here is -1, -2, -3, -4, -5, -6. And my highest value is +1, 2. Okay. If I didn't have a graph, because I'm not always going to have a graph with me when they ask me for my minimum and maximum here, what you can do is you can do to find the minimum, what we really did was we took our midline and subtracted the amplitude, right? We took -2 and we subtracted 4. We went down 4, and we got -6. For your maximum, you can do the midline plus the amplitude. So our midline here was -2, plus our amplitude, which was 4, and we got 2. Okay? So let's try to graph our next function here. So my next function is -2 cosine x plus 3. I look here, I know my new midline is at +3. I'm going to draw that in. 1, 2, 3. Draw your nice dashed line across. And now if I were to draw my basic y equals cosine x graph, I know cosine would start up at 1, go like this. But I actually have an amplitude of -2, which means a reflection over that midline and multiply by 2. So when I graph my new cosine function, I'm going to reflect it over this new midline, and instead of just going 1, I'm going to go 2. Then back to the midline. And then on the other side, up 2. Looking at my function here, my minimum value is at y is equal to 1, and my maximum value is at 1, 2, 3, 4, 5. If I wanted to use the formulas from above here, the midline was 3 minus the amplitude, which gives you 1. Okay, remember the amplitude's always positive. And if I wanted to find my maximum value, it would be the midline plus the amplitude, which is 5. Great. Exercise 7. Determine the minimum and maximum values and the range of each of the following trig functions. So here we go. The minimum. So again, we're following the formulas. So for your minimum, you're going to do the midline minus the amp. For the maximum, we're going to do the midline plus the amplitude. Okay, so the number at the end is your midline, and the number in front is your amplitude. So to find your minimum here, in letter A, you're going to do 4 minus 7, which is -3. To find your maximum, you're going to do 4 plus 7, which is 11. So this wave, this cosine graph, would go from -3 to 11. Let's try it again here. So letter B, your minimum will be 2 minus, remember the amplitude is always positive, 5, which is -3. And your maximum is going to be 2 plus 5, which is equal to 7. So the range here would be from -3 to 7. And then letter C, so your minimum is going to be 35 minus 25, which is equal to 10. And your maximum is going to be 35 plus 25, which is equal to 60. So the range would be from 10 to 60. Exercise 8. The graph below shows a sine curve in the form y equals a sine x plus c. Determine the values of a and c. All right, so this is really going to test to see if you understand what we are doing here. So a is your amplitude. How high is it going from the C, which is your midline? So when we see these waves, there's always going to be a midline that goes across here. I need to figure out what that is. All right. So how I can figure that out is, well, it's going to be in the middle of your y values. So what is in the middle of 6 and 22? So how you find the middle of two numbers, you add them, 6 plus 22, divide that by 2. So 28 divided by 2 is 14. This would be y is equal to 14. Okay, so the midline is 14. And now the amplitude is how high or how low this function is going. So I know that it's starting at 14, and then at this first high point and at all of the high points here, the y value is 22. So how far is 14 from 22? Well, the distance from 14 to 22 is 8. So your amplitude is 8. Okay. All right. It is your job to do for homework numbers 9 through 13.